All right, we're back. We're still on page 43. We're still graphing. I'm going to jump right into it. So I'm going to find the period. So the period is going to be 2 pi divided by b, which is 1/2. So people screw that up a lot. B is 1/2 because it's 1/2 times x, right? So you have to look for the coefficient of x, and it's 1/2 in this case. So this will be 4 pi, which makes the increment, the period divided by 4 is pi. The start, x over 2 equals 0, so x equals 0. This will be y equals 1. This will be y equals 1, and you can go up 4, so 5. This will be y equals 0 at 1, and you can go down 4, so -3. So can we space this out enough? We had to go from -3 to 5. Well, one thing that I can do that I can't do like usually is I can just like write it, and if it doesn't work, I can then just move it. So let's see how that goes. 1, 3, 5. What do I have to go up to? 5. Yeah, I'm gonna leave that. That's not bad. And then we got to put an x-axis, which I'm really becoming dependent upon that. That line that pops up. I'm going to put the center in the starting point in the center. So the center, I think, is here, but it may not be. Last time I never even put in the y-axis. Doesn't bother me. If I was going to put in a y-axis, it'd have to be like kind of maybe like here-ish, and that's kind of weird and awkward. So I just don't put it. You just need to make sure that you have this scale so that people know what's happening. As long as you have that scale, you're good to go. But your teacher may have an entirely different opinion on that. So make sure you check with your teacher before you stop putting in y-axes. If you were in my class, I'm okay with it. Like what if we're off in the 10,000s? What are we gonna do? Like, how are you gonna get 0 on that graph? But in this case, it's actually the starting point, so probably do it a lot. So I got to count by pi. So 2 boxes, 2 boxes, 2 boxes, 2 boxes. I think I spaced this out exactly the same as I did last time. -pi, -2 pi. I always label all of these. I mean, you don't really need to, but for whatever reason, I just hate it when people don't. Just seems like you should, I mean, there's a lot of stuff up in the air about these graphs. So this is a cosine graph. So cosine and positive, it's going to go maximum, intercept, minimum, intercept, maximum. Think of the unit circle, right? You're at 0 radians. You're at the ordered pair 1, 0. X is equal to 1. Cosine is equal to 1. It's the biggest it can ever be. That's a maximum. So you're starting at a maximum. You got to dot in a sinusoidal axis, though. So that's going to be at y equals 1. So do this, and then wow, nailed it. I'm gonna kind of sketch over that a little bit. It's hard to even see because I'm getting better, I guess, at putting that line in. I would not go so far as to say that. Just saying it kind of facetiously. Really, it's like a random. It's kind of a random process every time. Then I got to erase it. So there we go. All right, so we're going to start at a maximum. So that's at 5. So up here at 5. Then we go over here. We go over how many boxes? Go down here. Then we're going to go up here, here. And then we can actually get to there. And then go backwards. And again, if you mess it up, you'll notice. I mean, it's pretty obvious when it's not quite right. There we go. It's looking pretty good, I think. Hopefully it's right. I can tell that those are on the same level. And that should be it. So the range of this graph is from -3 to 5. The domain is all reals. So we don't really know how exactly to find the x-intercepts yet, but we can find where we hit the sinusoidal axis because that always happens at good points as far as these graphs are concerned. So when I'm talking about intercepts, I'm not talking about x-intercepts. I'm saying where does it hit the sinusoidal axis? So I'm going to list I only need 2, right? If you have 2 consecutive ones, you can always generalize. So I'm going to say x is pi, and then I need to add 2 pi, which is half of the period, right? The period's 4 pi. You get an intercept, you get an I twice per period, which means it takes half a period to get between them. So it makes sense that you get half the period there times n. N is an element of the integers. All right, and then, we're basically done, but I do want to point out you could pretty easily solve the equation f of x, or 4 cosine of x over 2 plus 1 equals -3. That's going to happen at 2 pi, and then I would say plus the period times n. So 2 pi plus 4 pi n, where n is an element of the integers. You could also pretty easily solve the equation f of x, or our function, equals 5. And I would say that that's going to happen at 0 plus 2 pi n. Nope, sorry, plus 4 pi n. 0 plus the period times n, not half the period times n. And then as I'm doing this, I notice I can pretty easily put in the y-axis, so I think I should. And then once you do that, you're kind of committed to like labeling things. I don't know what I'm counting by here. I mean, I'm counting by ones, but I've completely messed up. So now we're just doing all of them. That's okay. All right, there we go. So there's your graph. It looks pretty good. It's very straightforward. When the starting point is 0 is kind of like the ideal scenario, but it really doesn't matter. As long as you do starting point and increment, same denominator, you'll be able to just like add the increment all the way across. It'll be fine. So I'm going to stop this video here, come back in the next one, and do a little bit more. So I will see you there.